Alright, now let's look at the homework problems in 16.9, starting with number 2. And it just wants the Jacobian for x equal u squared minus v squared, y equal u squared plus v squared. So j is just the partial of x with respect to u, partial x with respect to v, partial y with respect to u, partial y with respect to v. And that's just 4uv minus a negative 4uv is 8uv. Okay, so that's all they wanted there. Number 8. We want to find the image of the set S. So S is bounded by u equals 0, u equal 1, v equals 0, v equal 1, x equal v, y equal u times 1 plus v squared. Okay, so if we draw this, u equal 0 is here, u equal 1, v equals 0 is here, and v equal 1 is right here. So it's a square. That's S. Okay, so we're going to first find the images of the boundaries. Okay, so this is A, B, C, D. A is v equals 0 for u in 0, 1. So if we go back up here and find x and y, that's going to give us x equals 0, y equal u, if we substitute v equals 0 in that. But u is between 0 and 1, so y is between 0 and 1. So if we graph it, we're going to get okay, so where u equals 0 and v equals 0, we're going to get the point x equals 0, y equals 0. So we're going to start here. So if x equals 0, we're on the y-axis is x equals 0, and y can be anything, but y has to be between 0 and 1. So 0 and 1, this is going to be the image, and we're going to travel up, because when u is equal to, as we travel this way on A to the right, we're going to the point 1, 0. So when u is 1 and v is 0, then we have the point x equals 0, y equal 1. So we're getting to the point 0, 1. So we're traveling up. Okay, so this is image of A. Let's call it IA. Now B. For B, we have u equal to 1 is the boundary for v in 0, 1. Okay, so if u equals 1, again we substitute them back in, and we get x equal v, y equal 1 plus v squared. Now x is between 0 and 1, and that means y is going to be between 2 and 1, because v is bounded between 0 and 1. So these v's right here are going to be bounded, and that's a parabola. So we're going to start it out at when u is 0 and v is 1, we're going to get x equal 1, y equal 2. no, we're going to start out at this point, I'm sorry, at 1, 0. So when u is 1 and v is 0, I'm going to get 0, 1. So we're going to start it out here, okay, and then as we travel up on b, we're going to get to this point, which is 1, 1. So when u equals 1, v equals 1, we get x equal 1, y equal 2. And we're traveling along a parabola, so we're going to go that way. So that's IB. Now C is this line v equal 1 for u in 0, 1. So if v equals 1, we get x equal 1, y equal 2u. So if x is equal to 1, we're along this vertical line, and y is between, so if u is between 0 and 1, then y is between 2 and 0 on that line, so we're right here. And we're going this way because when u is 1 and v is 1, we get the point 1, 2, and then when u is, okay, again, we're traveling, let's say in blue, this way. So we started 1, 1, and now we're going to go to 0, 1. So when u is 0 and v is 1, we go to the point 1, 0, which is right here. So we're traveling this way. And then, let's go back to black. D is over here. We're going from 0, 1 to 0, 0. So on D, u is 0 for v in 0 to 1. So x is v, y is 0. So we're on the x-axis. V is in 0, 1. So x is between 1 and 0. And we're on the x-axis. So when u is 0, 1, when we're at the point 0, 1, that's going to get mapped into the point 1, 0, which is right here. And then when u is 0, v is 0, we're going to go to the point 0, 0. So we're going that way, and this is image D. So our new region is right there. So that's the image of S. Okay, 12. I'm going to integrate this, and R is a parallelogram minus 1, 3. 1, 5. 1 minus 3. It's a parallelogram. 3, negative 1. Okay, so that's our R. We're going to, or actually, let's say that's S, and we're transforming it. And they give us how we're going to transform it. X is 1/4 u plus v, and y is 1/4 u minus 3v. Okay, and this is u, v. So let's see where all the points go. U 1, 5 is going to go to 3/2. No. Well, let's not do it that way. What we're going to do is get the equations of these lines. So first off, let's do this one. The slope is rise over run, so that's -3. So we have y plus 1 is -3x minus 3. So the equation is y equal -3x plus 8. The equation of this, the slope is 2 over 2, which is 1, so we have y plus 1 equal 1 times x minus 3, y equal x minus 4. Okay, this one, the slope is -3 also because they're parallel. So y equals -3x. And this one is y minus 3. The slope is also 1 because they're parallel sides. So that's x plus 4. Okay, so when we transform these to u and v, here the u's are going to cancel. Here I have -3/4 v minus 1/4 v equal -4. So negative v equals -4. This says that let's see, I think I wrote these down wrong. Okay, I did. This is v minus 3u. So the v's cancel out. I have -3/4 u minus 1/4 u is minus 4. U is 4. So that boundary in red is going to go to here. Okay, let's do blue. This one we have so here the u's are going to cancel out. I have 1/4 v plus 3/4 v is equal to 8. So here I have okay. Let's see. That's plus. So I have v equal to 8. So that boundary is going to get translated to here. All right, here I have 1/4. Oh, let's do this one in green. So the u's are going to cancel, and I have 1/4 v plus 3/4 v equals 0. V equals 0. So v equals 0 is here. Okay, and this one, I have 1/4 u minus 3v equals 1/4 u plus v plus 4. So the u's are going to cancel. So I have minus 3/4 v minus 1/4 v equal 4. I have v equal negative 4. Oh, that's u. I'm sorry. The v's are going to cancel out. So that translates here. So we have this rectangle. Okay, so we're going to change from this rectangle here that's like catty-cornered to a really nice rectangle, and this region right here is easier to integrate. So when we set up our integration, we have 4x, but x is 1/4 u plus v plus 8y, but y is v minus 3u. dA, we're going to, well, times the Jacobian, so we have 1/4, 1/4, negative 3/4, negative 1/4. That's xu, yu, xv, yv. Then we're going to do du, dv. And u goes from negative 4 to 4, and v is 0 to 8. So instead of integrating over those lines, we're going to integrate over intervals. Okay, so we're integrating u plus v plus 2v minus 6u. Okay, this is minus 1/16 plus 3/16. Okay, let me check something. This is a positive 1/4, sorry. Okay, that's plus, that's 4/16, which is 1/4. So this is times 1/4 du dv, negative 4 to 4, 0 to 8. So we're integrating minus 5u plus 3v, 1/4 du dv. So with respect to u, let's not write equals, we're just going to do one integral at a time. That's minus 5u squared over 2. Negative 5/8, 16 minus 16. Okay, so that's 0. Okay, let's see. Oh, forgot to integrate the 3v. Okay. 3vu. That's what I forgot. Okay, so that's 0. Now I'm substituting for u, so that's going to be 4v minus a minus 4v, so that's going to be 8v, and that's going to equal 6v. So I'm integrating now. 6v is going to be 3v squared, 0 to 8, and that's going to give me 64 times 2. $128. Let's see if I made a mistake here. Okay, so that's going to be okay. Well, that looks right. Okay, let's look at number 20. And 20, we have to pick our own change of variables, but it's kind of easy to do. If you notice, that is x minus y, x plus y, and here we have an x plus y. So let's let u be x plus y, and v equal x minus y. So then x, if we solve these, is 1/2 u plus v. We just add the two equations together, and y is 1/2 u minus v. We subtract the equations and we get that. So our region that we're integrating over is x minus y equals 0, x minus y equal 2, x plus y equals 0, x plus y equal 3, and that just translates to v equals 0, v equal 2, u equals 0, u equal 3. So we're just integrating over a rectangle. So to set this up, I'm not going to integrate it. 0 to 2, 0 to 3, e to the uv times u. The Jacobian is 1, 1, 1 minus 1 is minus 1 minus 1 is minus 2, so the absolute value is 2. Oh, it's 1/2. Sorry. Is minus 1/2, so the absolute value is 1/2, so we need a 1/2 here, and then we do du. Let's do v first. It'll be easier, then you won't have to use parts. So dv du, and v goes from 0 to 2 and u goes from 0 to 3. So this is what we're integrating. If we do v first, it's easier, because otherwise if you do u first, you have to use, again, integration by parts. Okay, so that should help you with some of your problems. Let me again fix something. I didn't multiply this right. Right here, I have 64 times 3 is 192, not 128. Sorry about that. That was number 12. Okay.